Let's do number 6. So we have a concave mirror. The radius is 40, so we know the focal length is half of that. The object is placed 10 centimeters in front, so that's P. The object distance is 10 centimeters. And based on that, we need the image distance, Q, and the magnification, M. So whenever we have P and F, we can find Q using the thin lens equation, or the mirror equation. 1 over F equals 1 over P plus 1 over Q. Now we need to do some algebra to solve for Q. We did this in class, but I can do it one more time. 1 over Q equals 1 over F minus 1 over P. Then you need to find your common denominator. So you're going to multiply F by P and this by P. You're going to multiply this by F and this by F. So now you found your common denominator. So now you have P minus F over P times F is 1 over Q. So to get Q, you're going to flip it and get P times F over P minus F. And then we're going to plug in the 20 and the 10 into this equation. And we're going to get negative 20. Keep in mind that the focal length was indeed positive because it's a concave mirror. And then to find the magnification, we're going to do negative Q over P. And the negatives will cancel out. You'll have 20 over 10, and you'll get 2. So we didn't have to do a ray diagram for this one, but if you wanted to practice doing a ray diagram, let's see what it would look like. So we're going to draw our mirror. It's concave, so I'll go like this. I'm going to draw the optical axis. Now this diagram is not going to be perfect since I don't have a grid here. So I'm going to put the focal length over here. That's my focal point. That's 20 centimeters. And then the object is placed halfway here. So I'm going to draw the object like this. And then let's see what happens when you draw the 3 rays. So we have one ray that goes in parallel. And then it's going to reflect through the focal point. So it's going to reflect this way. And then, again, it's not perfect. Then we're going to have one that is supposed to go through the focal point and reflect parallel, but the focal point is behind. So it's going to appear to come from the focal point this way. And then it's going to reflect parallel. Again, these should be straight lines here. I'm just doing a quick sketch. And then the third one would be that it appears to come from the center of curvature. Now because I don't have room, the center is over here, I'm just going to assume that these 2 rays are sufficient. We're just trying to get a rough picture of, do we really get something like this? So when we project this reflected ray backward, and then we project this reflected ray backward here, this one reflected this way. So it's going to project this way. I'm trying to draw a straight line. So they intersected here. It's hard to draw straight lines with this pen, but this would be the image. And we do see that it is about twice as big, and the distance is about the same as the focal point, you can see. So even doing a rough sketch gives us a good idea that we haven't made any mistakes with our equations. Number 7. An object is held at a distance of 12 centimeters from a convex mirror, creating an image that is 1/3 the object size. What's the focal length? So the first thing to realize is that if the image is 1/3 of the object size, then that means that the magnification is 1/3. And the magnification is also equal to negative q over p by definition. So we're also given p. P is 12. So from what we're given, we can solve for q. That's the only thing that we can solve for. So we're going to say q equals negative 1/3 times p by multiplying p over to this side. And we're going to get negative 4 centimeters. And the reason we want q is because once we have p and q, we can find f using that thin lens equation. So this time we solve for f. If you find a common denominator, just like you did over here, multiply this by q, multiply this by p, and then we get q plus p over p times q, which it might be easier to write p plus q. And then we see that f equals p times q over p plus q. And we plug in, our q is negative 4, p is 12, we plug those in there, and we'll get negative 6.